comes in, and immediately there's a few switches, protection switches. So power will come in, and there's this cover switch, which can cut power. There's this circuit breaker that can cut power, and then there's a e-stop. The e-stop and the cover switch run through this relay up here. So if you ever have a situation where there's no power, more on the service side, but if there's no power up here and you're like turning your hair out, what's going on? E-stop, cover switch, circuit breaker, and then I guess GFCI as well. Once power makes it onto the system, it will look for pressure to be on the outlet of the pump. Throughout the years, we've had situations where the pump has developed a leak in the seal because it's been run dry. So we added some software fixes to try to be more gentle on the pump. And so it's going to look for a pressure on the outlet of the pump, which tells it that the muni is connected, that the minimum pressure on the municipal is there, so it can turn on the pump and make everything run. So if you turn on the system, turn on the timer, is going to turn on the ozone system first. It will turn on the compressor and the ozone drive together. That's one solenoid, or that's one relay, this guy. And then a couple seconds later, assuming there's pressure on the outlet of the pump to indicate that the municipal supply has been connected properly, it will turn on the booster pump. It doesn't turn them on at the same time so as to not overload power and trip breakers. The ozone system will, what we know and love. So it's got the air compressor, which sends compressed air through a cooling coil to try to drop the temperature and allow any moisture to condense. That line runs in through a coalescing filter, so it allows the moisture that comes out as droplets to drop out of the line and not affect our sieve beds. Then the compressed air runs into our solenoid valve, which switches the pressured system to pressure and depressurize our two sieve beds. The solenoid runs to the top of the two sieve beds. It will pressurize one, allowing the air to have the moisture and the nitrogen absorbed out, and the feed gas of oxygen to run into our pressure chamber. And then after about 6 seconds, it'll switch and it'll depressurize the sieve bed that was just being used, and allow all that nitrogen and all that moisture to flow backwards through the solenoid valve and out through our outlet muffler, and also send a little bit of pure oxygen, or the concentrated oxygen, to flow back through that sieve material to help the nitrogen come off of the sieve material, to help that moisture come back into a very dry airstream and get out of our system. And the other sieve bed will be supplying oxygen to the pressure canister and the rest of our system. And it'll just go back and forth, generating about 93% pure oxygen. The 93% pure oxygen then runs through a pressure regulator and then up through a check valve and into a valve and gauge assembly, so we can monitor the pressure / vacuum that the system is experiencing and the amount of flow that is going through. We want to make sure that we don't overdraw the beds. So these can handle 15 SCFH, and so we have a 0 to 10. So if we keep it around 10 SCFH out, we make sure that we don't overdraw and potentially damage the sieve beds by pulling too much air through them. The concentrated oxygen then runs over to the other side of the panel and through a solenoid valve, which is to protect the sieve beds, to make sure that if the water system is running and for some reason the oxygen system isn't powered, that we don't accidentally draw air through the sieve beds and damage them. And then there's a inline filter that just is filled with a desiccant that gives us a indicator if our oxygen system is healthy. This will turn to a pink if moisture gets in there. That's a good indication that the oxygen system is working. And then into our ozone cell down here at the bottom, which is being driven by our HO drive board, high voltage transformer, and 24-volt power supplies. The ozone then runs through a bulkhead into the wet end. And on the wet end, we have, I guess this is a better angle. We have the municipal coming in to the system. It then runs through a pressure regulator, which drops the pressure to between 20 and 30 psi. To make sure we don't over-pressurize the system. And then through a solenoid valve that can turn on and off that municipal supply automatically based on the pressure in the system. And then water flows into the inlet of our booster pump. The outlet of the booster pump runs into there's a pressure switch connected up top, so it monitors the pressure on the outlet of the pump to verify that water is present and to make sure that the pump is not being run dry. And it runs into the inlet of our Venturi injector, which sucks that ozone into the water. This line has a vacuum relief check valve on it. So if the system's really rocking, you have an empty tank on your aircraft and you're pushing a lot of water through the system, so you're generating a lot of vacuum, we want to make sure that we're not generating too much vacuum that we might stress the electronics on our ozone cell. So we have a vacuum relief that will open up at about 10 inches of mercury and draw in ambient air to keep that vacuum at 10 inches of mercury. And then the outlet of the injector, now that we've injected our ozone, it goes into the contact tank. The undissolved ozone is allowed to come off the top of the tank and be destroyed through our water separator and ozone destruct. And the ozonated water leaves the tank at the bottom and goes through this port, which we plug into the drain port on the aircraft. And then the overflow valve port we will connect up to this is the return to the cart, and so water will flow to the aircraft through this line, fill up the tank completely, and the air that's being displaced by the water as it goes onto that tank will flow out of this the overflow valve, as well as water once the tank is completely full. So mostly gas at the beginning, but then also water begins to flow back through to the cart through this line. That runs to a pleated filter on the front of the cart. Pleated filter can remove particulate and anything that comes off of the tanks as it's being ozonated. And then the water runs after the pleated filter. It runs to this line, which allows any gas that's coming out of the tank as it's being displaced by water to flow through another degas valve that will run through our destruct system. So any ozone that's coming off of the tank will be destroyed, keeping everyone safe. And then once water eventually makes its way to the top of the tank and begins flowing back through the cart, the water will flow back down through a check valve and enter the inlet of our booster pump, creating a loop. So it will continue to draw water out of the aircraft, add ozone to that water, and send that water back to the aircraft, continuously adding ozone to the water on the aircraft until the dissolved ozone level in the water on the aircraft is within the correct range to do the disinfection step. and once it runs like that and builds up enough ozone concentration to run the disinfection step of running the water through the lines in the aircraft, that procedure can happen, and the disinfection is done. There's an automatic timer on the controls that allows the whole system to be automated, and it to automatically fill the aircraft, recirculate the water on the aircraft, build up that ozone residual, and then it will automatically shut itself down once the timer is times out. And a light lights up to let you know that the cycle has been complete, so that the operator knows where they're at. They can do other things that only be tied down to the disinfection process.
So, practically speaking, there's really not necessarily a need for the drain any longer?
The drain, it will no longer effectively or quickly power drain an aircraft. So what the drain function does is depressurize the system and allow you to disconnect the lines without worrying about getting yourself wet or the cart wet. And so once the disinfection process is completed, then we instruct the technician to go and close off all the valves. The lines will still be pressurized to about 45 psi. So close off the municipal system, close off the line running to the aircraft, close off the line running back from the aircraft, and then you can hit the drain button, and that will automatically start a process of opening up the valves, turning on the booster pump again to help draw water, and it opens up the drain solenoid valve, so it starts pushing all of that excess pressure and excess water through the drain line out to the sewer, and allows all that pressure to be relieved, so that when you go, and it'll automatically, using the pressure on the outlet of the pump, it knows when it's no longer pumping water. So at that point, after a couple seconds of low pressure on the outlet of that booster pump, it'll automatically shut down the drain function, and then you know that you can disconnect all of the lines without worrying about getting anything wet. That also happens if you run a disinfection disinfection cycle. Everything's pressurized. You go through and you close off Muni, you close off the valve running to the aircraft and running back from the aircraft. If you turn off the system, it will automatically open up the valves, turn on the booster pump, depressurize the system, and then once the pressure on the outlet of the booster pump drops below 5 psi, it knows that the depressurization is complete, so it'll shut everything down, light up the cycle complete, and turn off the system. So we do offer a reference of timing for various gallon size that might be on a particular aircraft. And so there's a fill time. So depending on the size of tank on the aircraft, various minutes that you would want to run the system at a minimum to fill the tank on the aircraft. And then there's a recirculation time to run in addition to the fill time to build up the residual of ozone on the aircraft. So if you have a 120 gallon tank, we estimate that it would take about 20 minutes to fill the tank through the AviOzonx system. And then once it's full, we recommend an additional 25 minutes of recirculation time to draw the water off of the aircraft, add more ozone, push that ozonated water back onto the aircraft, and build up the residual of ozone on the tank on the aircraft before the disinfection process begins. And so we give 65, 120, 300, 360, 450, and 600 gallon as a reference, but always we defer to the particular airlines that have standard operating procedures for the ozone cart. And so for the particular aircraft run in a particular airline, they will have recommended or specified timings for that specific airline. So we always recommend that the technicians use those timings provided by their airlines, and we just offer these as a reference. One additional safety feature I mentioned, the pressure gauge on the outlet of the pump, and wanting to make sure that we don't harm the pump by running it dry. So when you first start up the system, it will turn on the ozone, it'll turn on the oxygen, and then it will look to the pressure gauge on the outlet of the pump and verify that that is above 5 psi, which can be achieved if the Muni system is connected properly. So if the Muni system is connected properly, the pump turns on and it does its thing and runs automatically. If the municipal system is not connected, or the municipal valve is not open and water and pressure is not being supplied to the cart, then the pressure on the outlet of the booster pump will not exceed 5 psi. And so the cart will wait, and it won't turn on that booster pump, and it'll wait that maybe the technician is running behind, and maybe they'll turn on the valve. But after about 15-20 seconds, if that pressure has not increased on the outlet of the booster pump, it will alert the technician that there's something wrong by shutting the entire system down and flashing. All of the lights will start flashing 1 second on, 1 second off, and that lets the technician know, hey, I don't have pressure, so I'm not doing anything. So don't leave. Don't think that something's going to happen. There's a problem that needs to be fixed. If once the valve is open, the pressure is provided to the cart, the lights still flash. So it needs a power cycle to get out of that mode. So if you hit the e-stop, let the power, all the lights will dim and go off. Once they go dim and go off, then apply power to the system again, and it'll run as normal. And so as it builds up, it'll turn on and run water through the system, and then a gas bubble will come through, and so the pressure will go up above 45, and the municipal supply will turn off, and then that gas bubble will work its way out of the system, and then the pressure will drop below 45, so it'll turn the municipal system back on, add some more water, and then it'll get up above 45 and it'll turn off again. So the system is constantly drawing in water from the municipal supply, keeping that pressure up. If you're doing your disinfection cycle, you have the cart on, you're up on the aircraft, you're opening up valves and running water through the toilets and the laboratories, all that water is going to be supplied from the cart, and as you do that, the pressure will drop, the municipal supply will open back up, that valve will open back up, draw in more municipal water, ozonate it, send that up to the aircraft to keep the tank on the aircraft pressurized, allow you to run water through the water system on the aircraft without needing the aircraft on and pressurizing the tank.
I want to mention what we've discovered about when they mount these on carts and use generators with GFCIs built in, that we can't have double up on that.
Yeah, oftentimes the cart is used in an area where there isn't easy access to line power, land power. So they'll run these with a generator, and we have a booster pump and an air compressor on board the system, and it is well known in the industry in electrical systems that inductive loads such as motors and generators and GFCIs are tricky. And so with a generator attached to this and the generator supplying power to our built-in GFCI, we have had situations where the GFCI on our cart trips easily when it's being powered by a generator, when it's trying to push power through all that inductive load as we turn on our pumps. So our recommendation, if a generator is required to be used with our cart, that works. That is a viable way to use our cart. We just recommend purchasing a generator that has a built-in GFCI. Generators with built-in GFCIs use GFCIs that are designed to work with generators and understand as a generator is coming up or has power fluctuations, it can handle those better without giving false trips. So to buy a generator with a built-in GFCI and then remove the GFCI that is in our cable so that there's only one GFCI on the system, keeping everything safe, and that GFCI comes with the generator, so it is designed to work with that generator to make sure there isn't false trips. So that's our recommendation if the cart has to be used with a generator. The ozone indication light, when it turns on, is getting that information from the drive board itself, which is looking at the amount of current going through the transformer. So it's a very good indication of ozone being generated. We know that voltage is getting to the high voltage transformer, current is passing through the high voltage transformer. So if there is a fault condition on the board is shut down for some reason, this light turns off. You are running the system and you hit the drain button, the drain light will blink to let you know that it got the message, and once the ozonation cycle is complete and the timer times out, then it will automatically depressurize the system. If it's not currently doing an ozone cycle, it's just on, and you hit the button, then the drain light will come on solid, and it will automatically begin to depressurize the system until the pressure on the outlet of the booster pump drops below 5 psi, and then the drain will shut down. The cycle complete light turns on after the system is turned on and a ozonation cycle is initiated and completed. The cycle complete light turns on. That lets the technician know that it went well. If they hook up the system, turn it on, and then leave to go do other things, and they come back, that will let them know that the cycle is complete. There's a couple pressure gauges on the system. We have a pressure gauge on the outlet of the compressor to let us know that our compressor is giving the oxygen system the correct amount of pressure. That should be swinging between 15 and 25 psi. And then there's a pressure gauge on the outlet of the oxygen, which gives us how much vacuum is being generated by the venturi, as well as the flow of the oxygen through the system. We expect the oxygen flow to be around 10 SCFH, and the vacuum pressure will vary depending on if it's in fill mode or recirc mode, but typically is between 0 psi and negative 10 inches of mercury. And then we have a inlet pressure gauge on the inlet supply. That on fill will be between 20 and 30 psi. When it gets into recirc and begins to draw water out of the tank, this can go down to 0. There's a pressure gauge on the outlet of the booster pump that it is looking to get a minimum of 5 psi on that pressure gauge before it turns on the booster pump. Once the booster pump does turn on, it will start at about 20 psi and gradually increase as you get more water on the aircraft itself. That pressure will build and build. Once the aircraft tank is full, that pressure will reach about 80 to 90 psi. And there's a pressure gauge at the top of the venturi, on the outlet of the venturi, which is our best estimate of the pressure in the tank itself. And so that pressure gauge has a pressure switch connected to it, which tells the control board to turn on or turn off the municipal check valve or solenoid valve. And so that will keep the pressure on the outlet of the venturi, the pressure of the water going to the aircraft at about 45 psi, between 40 and 50 psi. and that makes sure that the pressure on the tank on the aircraft is well below 60 psi, so we don't have any concern about opening up the pressure relief valves on the tanks on the aircraft. So you have a thought, Glenn?
No, I was just going to, you already answered it.
The off-gas system, we have 2 off-gas vents that run through check valves that allow gas to come out of the system. That the gas will have ozone in it. So we want to make sure that we deal with that ozone appropriately. So the water, the lines coming off of these degassing valves will have some water droplets as well as the ozone gas. So the first step is to remove the water from the off gas. And so it runs into a water separator that's located down at near the bottom of the wet end. The water comes in, hits a T, and gravity will pull liquid oxygen down and allow the gas to flow up. There's a off-gas valve that's upside down that will fill up with water. Once the water hits a certain level, a valve will open and the water will drop out of the bottom of the cart. So if you ever see a cart in action and there's a little bit of water that happens below, that is just the off-gas vent doing what the off-gas vent is designed to do. Get rid of that water. Shouldn't be a lot of water coming out. The gaseous ozone that now has the water separated from it will run up and run through a chemical Carolite destruct, which is a catalyst that speeds up the conversion of ozone back to oxygen. It doesn't get used up, so it will last forever and continue to destroy the ozone effectively for the life of the cart, unless it gets wet. If something goes wrong and moisture is able to get up to that Carolite and get it wet, then it is deactivated and needs to be replaced. The 2 pressure switches are located here at the top of the control chamber. One is set to 5 psi, which looks at the outlet of the booster pump, and the other one is set to 45 psi, which is set to the tank pressure of the contact tank and the line running to the aircraft. The technician keeps an eye on the pleated filter and changes that out if it looks dirty to make sure that it's filtering the water properly.
Walk us through startup, hookup, startup, and run it through a cycle.
Okay. Brian want to be our guinea pig?
Okay.
Oh yeah, he does.
Sure.
Okay, we need to rotate it around. That's the return thing. Okay. The color code. Look at that.
Really has to go.
Yeah. Let's do that. Just
Thank you.
nice. So we got our Muni coming in. Got our line running up to our airplane, which is represented by our giant tank up there. We have our line coming back from the tank, from the overflow, and then we have our line running out to Muni. And our tank representing our aircraft is near full right now, so this is it'll be in fill for a little bit and then switch over to recirc quite quickly. Power is to the system. We got our power light, so we know that we're getting power from the power source making its way through the GFCI. All the cover switch is happy, the E switch is happy, the circuit breaker on the inside is happy, so we got a light. We're ready to go. If this were off, there'd be no light. So we turn the system on, and then we can turn our timer. So turn our system on. So we turn on the oxygen system. The ozone system drive comes on. Our ozone light is illuminated, letting us know that we're generating ozone. But we have yet to turn on our pump because we purposefully forgot to turn on our municipal supply. So it's being patient with us. It's waiting for us to realize our mistake because we still haven't heard the pump turn on. But at a certain point, it'll give up on us. So it shuts everything down, the ozone goes off, the oxygen goes off, and now all of our lights are blinking to let us know something's wrong. And so it did not receive more than 5 psi on the outlet of the booster pump, and it got sick of waiting. So it'll be in this mode, even if we turn on the municipal supply, it will still be in the locked out mode with the lights blinking until it receives a power cycle. And even turning it off with this power switch, still the lights are on. So we need to physically unplug it from the wall, or trip the GFCI, or kill it with the E-stop to remove power from the system, and then return that power, and then it will come to life. So let's kill it with the E-stop. The lights slowly stop blinking. So blinking, turning the power switch off doesn't affect the blinking. It still is going to require a power cycle. So I will trip the GFCI to cut power to the system. The lights stop blinking, and then if I reset the GFCI, the blinking has ceased, and now the system is ready once again to come on. So now if we turn on the municipal water supply, we can see what it does when it has everything it needs. So we turn that on, and then we'll turn the timer on again.